I know, yeah, when I first started, it was like, wow, this is real?
Yeah,
You know,
I did too.
looked...
When I saw it the first time, I was like, holy crap.
There we go. All right. Okay. So I'm Randy Berger, WA0D, and I'm going to go over a little bit about amateur radio on the International Space Station, or ARISS. And this is actually the second session. Yesterday I gave a session on kind of introducing ARISS and our capabilities and what we did with STEM and so forth. I'm going to probably cover maybe 5 minutes or less on that today, just to kind of give a brief overview for those that weren't able to attend yesterday. It was pretty in-depth. And then I talked about how to talk to the International Space Station too, or listen to it if you wanted to too. We have multiple radios on the space station today, which is really cool. We have lots of amateur radio operators throughout the world operating now on the space station and listening to it. And it's a lot of fun, actually, and it's pretty easy to do. So we actually started with the human spaceflight back in 1983, which was on the space shuttle. And so the space shuttle had a talkie, an Ericsson talkie, and they had like a David Clark head set up there then. Too, which was really neat, and so we were having a lot of fun with that with the space shuttle, and it ended up that they actually started trying out packet radio, which was really neat back then. APRS wasn't really alive and well at that point in time, but we did do packet radio, and that was super fun. They had kind of a contest with QSL cards to see who could be the first 10 people to do that contest and or contact the International Space Station, which was going to be the first digital contact through the space shuttle, that is, and back without commercial usage or support. And the cool thing was a lot of us were very, very successful, and I was actually one of the first 5 to actually be able to do that. And it was winter time, and it was actually a challenge because I was telling the folks yesterday my antennas were set up on a pole that was on a tire, a cement tire. You know a volleyball pole where you have a cement tire with the pole on it? That's what we had back then, back in the 80s. And so I had my antennas on it, and I was running in and out during the winter time trying to reposition it and everything. But I was very fortunate to make a two-way digital contact through it with a packet. I never had a chance to talk to Mir. So Mir was actually pretty active too for several years, and there was a number of amateur radio contacts with it, but we had a lot of amateur radio operators throughout the world that wanted to try to get onto the space station, and a number of those actually worked at NASA, both in several different locations, but especially in Johnson, Kennedy, and Goddard. And so it was asked if we could get onto the space station, and NASA actually came back and said, well, we're going to challenge you because we only want one voice worldwide for anything that happens on the space station from an amateur radio perspective, which was a really good idea, right? Because you know how it is, if you've got 3 amateurs, you've got a club, right? So, so this was really a good idea, and we got together with multiple different nations. We got with Europe, Canada, Japan, and Asia, and so forth, and it actually worked out. In 1996, in November, we got together as a group down in Houston, and we formed ARISS at that time. That was 26 years ago. So we've been alive and on NASA for almost, 26 years at this point. We were the very first payload on the International Space Station, which was really cool. And I'll show you that just a little bit where we were positioned at there. So that was a lot of fun. NASA actually recognized that we were backup communications for them, right? And there are several good reasons and practices that's happened over the years that it's a good thing that we are on the space station and maybe the future space stations too. We've been invited to be on the future space stations with Axiom, and we're talking to Northrop Grumman and Boeing and a couple of other folks too about being on their stations at this point. And so we've gotten welcome signs from just about everybody in regards to that, right? Because they realize our capabilities. Because typically, the way the communication capabilities are today with satellites and the space stations are, they're point to point, and they actually have satellites that are above them or in between the moon and that, right? And so if anything ever happens, you're not going to be pointed right at those satellites. So having amateur radio communications where we typically have antennas all over a space station like we do with the International Space Station today. We actually have 8 antennas on it. We go from HF, from 29 megahertz, all the way up to 2.4 gigs on the International Space Station day. So we cover quite a spectrum on the space station at this point in time. So it's a lot of fun with what we're doing. And I think, like most of us, we know, and we have, from an amateur radio perspective, fun talking to the space station and listening to folks that are up there too, and talking to the astronauts. The school thing is a pretty big thing. We've been doing that for a number of years, right? It actually has gotten a lot bigger because we're really focused as an organization from ARISS, focused on STEM education, and NASA actually helps provide quite a bit of funding, and so does the European Space Agency and some other folks too, including like ARDC has helped us out also with a $1 million grant a year ago. So we get typically on the order around $6 million a year in funding for STEM and projects and things that we're working on, which was pretty significant, right, when you think about it. And we're really fortunate that we're fairly well recognized in the space community and regarded too, because we haven't caused any problems. We've actually helped in a number of instances, and so we get opportunities for payload lifts going up, not only with the NASA's rockets, but with Northrop Grumman, SpaceX, and the European space community too. And so that's actually been really good for us. We really can get on those payloads, which, you know, from a satellite perspective, you know, from AMSAT perspective, a number of us are AMSAT members like myself, and it's really hard to get a lift or a ride, right, to get that paid for and do that. So we're really very fortunate over on the ARISS side to have the connection that we have today. But we have 3 initiatives that we really focus on. So the first initiative basically is building space hardware for the International Space Station and other things that are coming up in the future, like the Lunar Gateway. We're working towards that at this point in time. Pictured here is kind of the latest equipment. It's the Kenwood D700. That is the radio on top of that box, which the box is the power supply. We call that our multi-voltage power supply. We actually built that ourselves. And it is a tremendous feat, actually, because it's not something that's simple. That power supply actually has, as it says, multiple different voltages, but the Russian segment does 1 voltage, is that 28 volts, what they use over on the Russian side. We use 120 volts over on the US Columbia side. And it's not AC, it's DC. So this power supply is very specialized in what it does, and the capabilities, and then it outputs a whole bunch of different voltages, and I'll show that here in just a little bit, I believe. The outputs have been well tested. We've gone through certifications with NASA. It was like a 700-page test thing that we had to go through, and it took a lot of time to get this done, but we now have it certified. We have 10 units that are available. We have 1 up on the space station right now. We're going to send another one up for the Russian side, but it's looking like that we may use the other power supplies for the newer space stations that are coming along, right? So instead of us having to build a whole bunch more, we can make use of those. And since the International Space Station is going to be maybe decommissioned sometime in the the 2030s, that would actually help us out, because Axiom's coming online, and we'll probably give one of the power supplies to Axiom, so when we go on the Axiom space station and so forth. The other thing is that we work with the kids, right, with the STEM education and so forth, so we're really pretty big into that. When we first started with the astronaut contacts, it was pretty straightforward with contacting the schools, kind of setting things up, and kind of working with the teachers and administration. And then the amateur radio operators kind of making the contacts or helping set up the contacts and the questions that were sent to NASA. And so the astronauts knew what the questions were as the International Space Station comes up for the contact, and they're able to talk to the kids, which was really neat. We actually surpassed 1,500 school contacts here this past December, which is a huge, huge feat, right? And we believe that we've had I think over 5 million people that's witnessed this, right? Which is pretty amazing, and it's really good for everybody, especially the kids, right? And what we've done in the last several years, maybe in the last 10, 15 years, is we've moved to more of a structured type organization on the school contacts, and the fact that we want to teach science, technology, and education, arts, and math, and so forth, right? Engineering pieces of this, and so. Before the schools can contact an astronaut or have that contact, right, we go through some educational things with the schools, right, with science programs, and help them out, showing them different things. And I think I've got a couple of pictures that will come up here. But that actually has been pretty good. So they get a semester long, at least, 4 months, sometimes 6 months, of educational pieces where the kids actually get to do things, right, and help out. So their interest may not be in engineering or amateur radio, but certainly space or talking to an astronaut is really cool, and maybe the kids like art. So art is one of those things, part of STEAM, right? So we do things with art with them and so forth, and so that's part of it, what goes on. We also manage and operate the radios and so forth on the International Space Station. We have a consultant, paid consultant down in Johnson, that Kenneth is on site as a NASA employee, and he's there every day. He's helping with school contacts and everything else, right? So he's a paid employee down there, and he does a fantastic job helping us out. So every week we have operational meetings too, looking at what goes on for the following weeks coming up, and so it keeps us pretty busy on what we're doing, and we definitely have weekly contacts pretty much most of the time. We'll have between 80 to 100 contacts through a given year, which is a lot of contacts with schools, right? And it takes a lot of skill and patience sometimes, because we're doing things worldwide. We're not just doing things in the United States. We're doing them over in Russia, in Asia, and so forth. So setting all this up in the mechanism, getting it working, is a lot of work for everybody, but it proves out to be very nice, and I'll show you a couple videos of that. This is the space station today. And when we were first came on as a payload, it was the cargo area in the middle was the first area for us, and in the late 1990s, we were the first payload on the International Space Station, which was great, and we have pictures and videos of that too, right, which is fun. They consider us as a pretty significant payload on the International Space Station at this time. And for many, many years, that was the only way for them to talk to their families and so forth, was through amateur radio, until they got digital communications and so forth on the space station in about I think around 2004 or so, when we first started putting stuff up on it. But there for several years, amateur radio was the way they talked to their families, and that was neat. Today we have stations in the Russian side too, and we have our station over here on the Columbus side also. I'll make note that the Japanese side actually has the launch bay, which we launch out the CubeSats out of it over in this area too. But between the Columbus module and the service module and a couple antennas here, we have 8 antennas that are on the space station today. The HF antenna is actually down here on the Russian side. We're considering how we can get an HF antenna over on the U.S. side right now, because we're looking at doing some SDR work, right, with software-defined radio. So that's going to allow us to do a lot of different things here in the future, and that's the reason why we're looking at that. Especially with space weather, because we're looking at doing and helping out with space weather from the space station too at this point in time. So the kids basically, this is kind of what we do for the programs for the kids, right? So we get them used to talking on the radio, so out of a school that has several hundred kids, there'll be 10 kids that are picked especially to talk, and so we'll visit and work with them maybe a couple times, getting them on local repeaters and so forth, talking, and then we'll also practice with the questions too the week before the contact with the astronauts, and then we build out electronic kits, so part of the funding from NASA. Then we give out electronic kits and stuff that they'll build out and having fun, and then physics, right, showing how to generate power and solar panels and so forth, and then the art. So we do quite a bit of work in that semester with everybody and how we work together. So we have done 63 countries around the world, which is really pretty cool. We've done 49 states. South Dakota is, for some reason, the last couple of years, been really pretty hard for us to get school contact there, but we're working on that. So that's the only state that we don't have that. But we have, lots of people that watch us all the time on videos and everything else, and so the experience is all for the kids, right? As you can see here, their faces and how they enjoy the contacts, and being able to talk to an astronaut is really pretty cool. So what I'm going to do now is cover our highlights from last year. So I was here a year ago, and I spoke a year ago, about ARISS, and kind of went over a lot of stuff. And I certainly can talk about or answer any questions that you may have that you may be thinking about. But I'm going to just kind of go over the highlights from last year. One of the coolest things is that NASA just put out a really nice video a couple weeks ago on their highlights from 2022. And the opening thing is amateur radio. this is the opening. This is really the coolest part, right? Them showing us right at the very beginning. We couldn't believe it. We were like so thankful that they did that. And so throughout the video, they did talk about amateur radio, how Jill talked to lots of different continents and so forth. And he was up there for, I think, a little over a month. But man, this guy, he was busy back in August and September. He was on the air all the time. Every time I travel quite a bit, so when I came home on the weekends, on Fridays and the weekends, it seemed like he was on. I was surprised, and he was on so much that I think people didn't even know it, because there would be times when the space station was coming in over, and he was calling NA1SS, right? And nobody even recognized it. They were trying to talk to everybody else. So then I'd have to jump in and coordinate that, right? And then once I realized it was, hey, this was an astronaut, then it was all focused on that, right? Which was really a good experience for everybody. But he did have super contact with an 8-year-old, which was really pretty neat.
Lima, Mike Kilo. This is NA1SS. Welcome to the International Space Station.
November Alpha 1, Sierra Sierra. Mike 0, Lima, Mike Kilo. My name is Isabella. I'm 8 years old. You're 5 and 9. Thank you.
Mike 0, Lima, Mike Kilo. This is November Alpha 1, Sierra Sierra. Isabella, it's so great to chat with you. Thank you for getting on the radio and saying hello.
Thank you, fly safe.
Speaking to an astronaut live on the International Space Station might be one for the bucket list, but for 8-year-old Isabella from Broadstairs, it was a regular Tuesday.
It was very amazing to talk to an astronaut, and I was amazed. It was like deja vu had come to me and granted me my wish.
And when you were talking to him, what were you thinking?
I was thinking, oh my goodness, I'm talking to someone out of the Earth's atmosphere.
Her dad Matthew is a licensed radio amateur, and since Isabella was a toddler, this is the room they've been experimenting in broadcast together. So she's got Dad to thank for the experience.
I'm not going to lie, I was a little bit jealous that it wasn't me talking to him, but it was amazing seeing Isabella have that contact. It's quite unusual that the astronauts on the International Space Station actually use the amateur radio equipment, but they have been known to do it in the past. So through the network and through the communities that I'm involved in, I had word that the astronaut that was up there was using the equipment. So we just started listening out for him. And it was just a game of luck, really. You know, you have to get the right time when the space station is passing overhead, and it has to be the right time of day when the astronaut's actually using the equipment.
I've had that dream of becoming an astronaut for as long as I can remember.
Chell Lindgren was the man in space who picked up the signal. He even tweeted Isabella to thank her, saying it may have been his favourite contact so far, and he also sent her this picture.
I really want to inspire other little girls, and I want them to know that just because boys have all the space clothing doesn't mean they don't have to love space.
Who knows what this pair will do next, but something tells me it's going to be out of this world. Josie Hannett, BBC News.
So that was just this past year. So that was really cool, right? And it was really amazing. So this was just kind of a summary. I presented this at the AMSAT conference here a couple months ago. But we've had a total of 81 contacts last year. You know, COVID and everything's still going on. So a lot of these, you know, we couldn't do at schools. They had to have children remote. Some of these places, which. But 21 of them was in the U.S., which was really neat. We did 16 telebridge contacts too. So we have telebridges throughout the world, actually. We have like 16 of those and are able to put schools together. So a lot of times when we don't have amateurs in certain places, that's what we'll do. We'll hook them up via the internet pretty much and let them talk to the astronauts, which is nice. Yeah, so a couple years ago was our 20th anniversary, which was really pretty cool, and we did a school contact during that time too at Burbank, and that was pretty neat. I mentioned before that on the Japanese side we were able to launch CubeSats. Well, just like this past December, we launched 3 CubeSats from the Japanese side, right, which are active right now. I think they're the SA something or SS something CubeSats at this point. I haven't used them myself, but I know they're active and that they're working. So. And this past year, we did a number of things. You know, I did Cowtown. I didn't have a picture of Cowtown here. I should have had one in there of that. But we did Hamcation down in Florida, and we had a tent full of people during their talks. I had the CubeSat on a plane, taking it there, and just like right now, this CubeSat here actually is working right now. You may not know that, but it is taking pictures of everybody right now. So give a wave, right? There you go. On the space station itself, we have new equipment up there. This is the Kenwood D700 and the power supply that we were talking about before, the MPVS, right? So that is mounted up there, which is pretty new within the last couple years. And then last year we actually got over on the Russian side. The same radio is set up over on the Russian side right now, but it's as you saw, I think, on the video prior to we started talking here, they have things velcroed to the walls, which is kind of different than the way we do. We have arms and so forth to be fasten stuff. And I actually have equipment on the International Space Station too, so this is actually the high-performance compute that's on the space station that does machine learning and AI for them, but we're mounted just a couple feet away from that, on the Columbus module, which is really kind of neat. We've done a lot of things for NASA in regards to what I do professionally, and one of them, which I'm not going to play the video here, but is using AI to look at the gloves. And so what happens today when they go out on an EVA and they come back in, they have to take hundreds of pictures of their gloves, right, and their spacesuits, right? And then they take a whole week, because the bandwidth from the space station is really low, to send those pictures back down to Earth. And it takes another whole week for analysts on the ground to look at all those pictures, determine if there's any cuts or anything and what's going on. We started using machine learning and AI on the space station this year too, and Microsoft did the coding for this, but we're now able to look at the gloves and stuff in 5 minutes and determine if they're okay or not. And the reason this is important is kind of twofold. One is on the International Space Station, they only have 2 sets of gloves. One is one that they use to go outside, the other one is the emergency set, in case they got to leave the space station. So if they have a ruined pair of gloves, they don't ever get to go back outside unless it's an emergency, but that they pretty much have to come back, or we got to send new gloves up to them. The second reason is that when we move to the moon and to Mars, it's going to be really difficult to replace gloves and everything at that point, and there's no way we're going to send pictures back and forth in those time frames. So this was really pretty important for NASA here last year, and the capabilities that we did with that. And then we went to Hamvention. We were up at Hamvention. This was our booth, and wow. It's in a smaller building, but the thing is, it was in this prize drawing building, and there was only one aisle like to get to it, right? We had 27,000 people coming. It was packed all the time. We couldn't even move. It was amazing. So we did have a lot of fun at Hamvention, and it was big. There was lots of, there was like 20 acres of a flea market out there. Saturday afternoon, it was stormy. If you go to Dayton, it has to be bad one day at least up there. And it was like hail, and they had tornado warnings out. So everybody was crowded in the buildings at that time. But it was still fun. We had a lot of fun up there. We did have a conference at the ISS R&D conference this year too. It was the first time I got to go to it, and it was up in the DC area. But man, we had thousands of people stop by the booth and everything up there too. I was with my friend Chris, and I got my picture sent up to the International Space Station. You would laugh if you saw us, because it looks like I'm a little taller than him. He's actually like 6'5", man. He looks so that was fun there. And this is Dave Taylor. Dave Taylor does a lot of work for my engineering team that we have, and so he does all the work on the radios and coordinates our stuff with AMSAT too. So now I'm going to talk about kind of some of the things that we did last year from an engineering standpoint, because I'm the executive director for the engineering side for ARISS here. And I have, I think around 30 people worldwide that are helping us on the engineering capabilities and what we're doing with the interoperable radio system up there. But one of the things that we're doing, we got a grant from NASA, and NASA is funding us to build out a new sensor system for kids for what they call a virtual mission control. So this virtual mission control is going to allow students on the ground to receive information from our sensors back down and look at that information. And the University of Berkeley got the other half of the grant to do the software side of it. So right now they're building out the virtualization piece. We're doing the hardware piece, basically putting it up there. And at this point in time, I actually have these are the sensors that are going up there right now. So we have 11, but I count it as 12 because we're controlling the radio too. So we're taking away the APRS side and everything. We're putting that all into a Raspberry Pi that's built into this, and so we're detecting all these different things. But probably the two biggest things, well, maybe three, is the gases. We're detecting every type of gas you can think of, right, that you could detect, whether it is alcohol, CO2, or whatever, right, or methane. The educational people thought the methane thing would be really pretty good, because if astronaut farts up there, they're like, okay, we can figure. So they were really smiling and happy about that. And I'm like, okay, well so we've got 3 gas sensors, that the whole range, the whole gamut. So the students, and they can look at everything basically. But we also have a radiation detector too. So we're looking at the astronauts while they're sleeping, and of course radiation's a big concern up there. But when the astronauts are sleeping, they can see white things kind of going through their eyes at night, and so it's like, so we're going to try to detect this stuff with what we're putting up there right now with that. So that's one of our sensors. And then the other part is that we have an ultrasonic microphone, which goes from 0 to 90 kilohertz. And the importance of that basically is we're going to be listening for vibrations and so forth inside of the space station. We're really not going to be listening to the conversations, because we're not supposed to do that, right? But we're going to change that into an FFT type analysis is what we're going to do with that side of it, which will be pretty fun. So this will be pretty educational for students. And again, we're using Raspberry Pi 4. We do have the Arduino for the actually for the radiation detector part of it, because that came from MIT. MIT developed that, and so we're using that, which is really neat. The schematics, I pretty much entered all the schematics from all the people and everybody that's helping out with this, but we've got about 11, 12 pages of schematics, and I organize it real easy so we can click and go to anything on the sensors and do that. And then the boards, I do have a picture of the boards coming up here. The specification, we finished the specification pretty much last year. It's about 50-some pages long right now, which is pretty detailed, actually. And then block-wise, right, you can see how we're organizing it with the pins on the Raspberry Pi here, using pretty much the I2C bus for the interface and some of the USB features. There's a Dennis out in Colorado, you'll see in the QST magazine, he did an interface called DigiRig. And I used that interface. I have some radios and stuff down in Costa Rica, and I've used that interface down there, and it has never failed on me. So I've asked Dennis to use his schematics and his stuff for the interface for the radio, which we did. So we've incorporated that into it, so now we can control the radio and everything remotely, and pretty reliable too, I think, at this point. And that kind of shows how the connectors and so forth are connected into the radios themselves. And we do have a real-time clock. The other thing that I decided to do, and I asked Karen over in the UK, one of the engineers helping us out, is to look at using SSTV with the Raspberry Pi. So we actually have that now working with the Raspberry Pi, and we've been experimenting with that. So before we had to use one of the laptops on the International Space Station, right, for this, which you have to coordinate and schedule that with the operation of the space station. So now we won't have to do that type of thing. We're going to use the Raspberry Pi 4 for that, which was nice. And the fortunate thing about this is we already have this developed and everything, but about a week ago, maybe 2, the laptop that was running the slow scan TV for us, and it's over on the Russian side, it actually is broken now, so we can't use it at this point. So it's probably pretty good that we did this and set this up that we could use the Pi. We were looking at where we could put the boards for the sensors, and so the first idea we kind of had was kind of like a CubeSat design, which is 100 millimeters by 100 millimeters, and that was actually really pretty cool, and it was going to go in this spot, but it's a really tight spot right here above the multi-voltage power supply. But after thinking about this for a little bit, we actually changed our minds, and I asked NASA if we could put something in between the plate that's at the bottom and the power supply, the same size as the power supply, and the answer was yes. And the idea behind this is that we're going to get a lot more room, right, of course, and so the capabilities of this, we're going to get all of our boards into like half of this section underneath of the power supply, and the other half I'm planning on using for the SDRs. So we're looking at a ton of different SDRs that are capable, that can go up there, and what we can do with them. So This is a picture of the sensor board, basically. The 40-pin connector for the Raspberry Pi, and then it has the gas sensors. These round things are the gas sensors on there, and the other sensors are on the board also too here. So looking at underlying underneath the power supply is we're building a box out that is basically 11 by 9 inches. That's how big it basically is, and we're going to split it up in two different cabinets or rails that we can put slide stuff into, and we'll have a back plane on the back that these boards will fit into to get power, and the fan and everything will be in the back side of it here with that capabilities. Yeah, so we had the ham TV, the digital TV on the International Space Station. It was working great up to about 2017, and then it quit. The FPGA had a problem with it, what we were told, but the capabilities of it was to send back digital TVs, pictures, and mostly the Europeans were set up for this, which is, they've been doing a lot of work on this. We did have like 3 or 4 stations in the U.S., but they did, the British ATV group did a really good job in creating a piece of software that stitched all these pictures together, which made them look seamless, which is really cool. So as this thing was transmitting, we were actually able to take pictures throughout the world and put them all together, which was really nice. Kaiser Italia was paid by the European Space Agency to build this out for us, and it did a good job for I think a couple years. It functioned, and then it quit working. So we sent it to them. We brought it back down on a payload. We sent it over to Italy, but because of COVID and everything else, it took almost 6 years, 7 years for us to get it repaired. So we do have it working now. I was down at Johnson here in December, and it's functioning pretty good. We're running it through a whole bunch of tests at Johnson. We're hoping we can get it back up to the space station by May, because we have an astronaut that we trained in December on this down at Johnson while we were down there, and so John's going to go up and hopefully he'll be able to use it and do some things with kids and so forth. So we're really looking forward to that. It does take a little bit of capabilities on receiving this, right, because it is at 2 gigs. It's at right at 2.4 gigs here for bringing it down. So you got to have a little dish and be able to move that, right. So it takes a little bit of work. It's a little harder to use in the 2 radios we have on the space station today, because you can pretty much use any antenna. I showed this yesterday. You could use a 5/8 wave or a quarter wave to receive the space station on the voice, the gateway portion of it, or over on the APRS side, over on the Russian side. With the digital TV going up, you have to have a little bit more equipment for that, and we do have information out there on how to set that up and how to use it. This is actually Kenneth. He's down at NASA, and he's there every day managing everything for us on the space station, which is really neat. And this is Carrie. Carrie actually volunteered to do the testing with us while we were down at, he lives out in San Diego, but Carrie did a lot of work on this, but he also developed, Carrie was the guy that developed the power supply for us, and he came from Qualcomm, and he had a quite extensive background on analog, and so that actually helped us a lot. I don't know if I mentioned it or not, but that power supply has no electrolytics in it. Try to design a power supply with no electrolytic capacitors. It's almost impossible. And I am just really amazed that he was able to do that. It was really pretty cool that he was able to do that.
Is that design publicly available, or is that proprietary?
No, it's public. Yep, so it's public. So we actually have schematics and everything. So
we can do it. We can build it ourselves.
Mm-hmm. Yeah. Yep. Absolutely. This was us last month down there at Johnson in December doing the testing. This is Greg. He's a NASA employee. He's actually the antenna designer, and I don't think I have it in here, but he actually designs not only the antennas that go on the spacecraft, satellites, and so forth, but on the suits. They have the antennas built into the suits too, and he designs all of those, which is really pretty impressive. He showed me a couple of those and the capabilities of this.
Does he live out in California?
Carrie does, yes. Carrie lives down. Oh, Greg is down in Johnson. He's at Johnson down in Houston. We're kind of laughing here because they had very little experience with wattage, and Ham TV puts out 10 watts, right? And they were going to dump that right into their spectrum analyzer. And Carrie's like, no, 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 don't do that, right? We need some kind of attenuator and so forth. And so they tried to find an attenuator, and this little attenuator was getting so hot, it was like crazy. So then I said, well, we need a duplexer, or diplexer. Let's try to funnel some of this off to a different port. And so it took about a day, but they did find one. NASA had one, and so they brought it over, and it started getting hot. And I'm like, and the reason we're laughing, I'm like, okay, let's put a heavy plate on this, heat sink this off. So this is the plate that we're heat sinking that 10 watts off, right? And it worked pretty good, actually. So we actually did all the testing. We had to develop, they changed the cameras on the International Space Station from using basically RCA type style raw video input to HDMI, right? So all the cameras are HDMI now. And Art built this for us. He built I think he built 5 of these. But it converts the raw video and HDMI coming into raw video going into the ham TV, because we couldn't rebuild the box, right? Because the box itself takes in the raw video. So we had to come up with a way to do that. And at the same time, we thought, it might be a good idea if we ID from the space station too while it's transmitting. So he built in an IDer into this board here is the IDer. And this converts it from HDMI from the camera to raw video. But did a really good job. Him and Lou put this together. Lou actually did the cables for this, and we put this together, and we're testing it right now to try to get that up there. So the last part of this is I'm going to talk about we're working to try to go on to the Lunar Gateway. We have no promises yet from NASA on that. I want to make that clear. So if this goes out on YouTube, but we're trying to work with NASA on what we can do for the capabilities, and we're really looking forward to that. And I've had, because of my business practice, I've had several conversations with them about the Gateway and the capabilities, and from some of our internal NASA friends, they've actually doing the same thing. So we're coordinating some talks right now and trying to bring it up. And the biggest thing is that on the space station, there's always an astronaut on the space station today, right? With the Lunar Gateway, there's only going to be an astronaut on the space station or on the Lunar Gateway every 3 months out of the year. I mean, most of the time it's going to be going around the moon by itself, right? So it's not like we can have somebody go flip a switch or do something for us, which we do today. So it's a little bit different, and it's going to take a little bit more work on our part to make sure that we have something that's bulletproof. And quite frankly, having it out near the moon is a lot more of a challenge, because besides having somebody to help us there, the radiation belt is the radiation's a lot stronger out there, right? So we're going to have quite a bit of protection with that. So you guys know about Artemis went up and around the moon. The Artemis 2 is getting ready to go too, but basically we're trying to plan on and trying to look at it 2 ways. One is we want to be on the Gateway. We're looking forward to that with the talks that we're having at this time, discussions, so which is nice, and we're in the process of figuring out what's the most appropriate equipment to have up there, and we have thoughts already about what we want to put up there, but we've got to listen to NASA too. I thought I'd show this too, because there was questions about satellites too. So when Artemis is launched, it has Orion on top. So Orion goes around the moon on that previous picture. Artemis is the booster, right, that just carries it up. And one of the rings has the CubeSats built into this. This is CubeSats. These aren't small, right? They're not the 1U. They're like 12U, and they're big CubeSats here. They had that completely loaded on Artemis this time to go up, which was really cool and really neat. And we were all looking to listen on all these frequencies and everything for all their CubeSats that they had going up. But because it took like an extra year, their batteries were all bad. None of these satellites, none of these CubeSats worked after they let them go, which was really pretty interesting. And actually, so the really good thing was they did ask AMSAT about putting a satellite on here, right, a CubeSat, and for some reason we were not ready, and so we had to turn them down on that. And probably a good thing, because it would have been a waste of effort because of the delay. I mean, it wasn't the CubeSat folks that built those CubeSats' fault. It was because of the hydrogen leaks and everything else that we had with Artemis a while back here. But looks like they've got that remedied at this point in time. So antenna polarization is pretty important, right? So the thing is that when it goes up, comes down, it kind of reverses itself. So you've got to have the antenna polarization just right on the kind of way that is. So the Lunar Gateway is going to take a little bit more specialized piece of equipment. And the way I'm looking at this right now, it's not going to be like the CubeSats we have today, which will be voice or with FM or with sideband. It's pretty much going to be digital communications coming from the unit because of the losses and so forth, right, is going to be really low. So something like FT8 is going to be the better way of looking at talking to and making voice conversations and so forth. So that's kind of the direction we're moving towards, and it's using SDRs, right? So a simple SDR today, like $20, you can receive digital communications from pretty much all of our satellites that we have for amateur radio operation, and you can also use this for receiving packets too, looking at packets from the International Space Station for $20, pretty cheap. The stuff we're looking at going on the gateway is going to be several hundred to thousands of dollars probably for the SDRs that goes on that. This one actually is called Pluto, and the cool thing about it is it's made by Analog Devices right here, and I ordered one a week ago. Mauser has thousands of them stocked up, so I got this within a couple days. But it's being used over in Europe right now extensively for QO100, right, for the digital thing over there. So they're doing voice communications and receiving pictures with it, because it's not only receives, but it also transmits. It's got a transmit port on it too. So so it does full duplex, which is really cool. The other cool thing about this particular unit is that not only can it do receive and transmit, but it can do two of them. So inside of this, it's got the extra ports already built into it. So we figured out how we can drill holes on the top of this and have two transmits and two receives, and so you can do a lot of things with this. So the hams over in Europe have these in boxes outside by their dish antennas, and are talking to and sending pictures back and forth, which is really neat. The BATV guys, which I'm having a conversation with tomorrow, actually, we're in discussions on next generation of ham TV. So that blue box I showed before, we're looking at replacing that box with an SDR like this, right? And this is what they're using right now. So probably in the future, in the next couple of years, we'll be replacing that box with something like this going up there. Now, when we look at the Lunar Gateway, I don't know if there was a satellite that was sent up called Capstone, and it was sent up prior to the launch of Artemis, right, back in the middle of the summer, and it was really pretty good thing. And I took a lot of interest in it because I wanted to know what type of antennas was on it, right, and how it was being used, because my planning for what we're going to do with the Lunar Gateway is like, and the thoughts was we're going to have to use patch panel antennas. That's what this uses right now, is patch panel antennas on it and the capabilities of that, right? So you can see how they've got the low gain antennas and a high gain and a super long range antenna, which I'm still trying to figure out how they use that antenna with the way they show the positioning of the satellite when I show you some next things, because it's never pointing towards the Earth. So maybe there's a satellite that's further up from the moon that we don't know about that they're using that with here. But it is really interesting about that. And I've been talking to Kent Britton about patch antennas and so forth for the exterior of satellites, because he's done some commercial ones and so forth. And we have another gentleman down in Florida that's also built some things, and he's helping us out too. The orbital path of it is kind of really weird, kind of how this goes. And so the orbital path basically of the Capstone, or how the Lunar Gateway is going to be, is like this, going up and down around the moon as it's going around. So it's pretty interesting how the paths go here. So this is how it looks when it's the Capstone was up there in the Lunar Gateway. We'll also be doing the same thing. We were going to put the Lunar Gateway up first and then go to the moon from that, but that has changed in the last year or two, that we're actually going to go to the moon first and then we're going to put the Lunar Gateway up. It's going to be following that, which is probably a good thing. I think the idea is we want to beat the Chinese to the moon, or other space organizations to the moon, and have our presence on the moon here. So probably go check our flag out. I don't know. So, but that was pretty good. So I'm going to talk a little bit about the space communications. I had a slide in here, but because we're recording this, and I didn't want to put what we're doing exactly on the moon, so I've got another slide. But this is what happened with the Apollo series, which was really pretty interesting. The communications were single path, right? There was no full duplex or anything back and forth. So this is using like 2.8 gigs kind of going up to the capsules and so forth. And then on the moon, they were using 296, 298 megahertz direct communications back and forth. And it took me a little bit to think about that, and because I was wondering, like, why aren't they using like a repeater, right, and duplexers? And the reason is that those duplexers are, you know, for 400 megahertz are still pretty big. so they would decided, let's just use the paths directly, right? Well, if I showed you what was going on in the future here with the moon, it looks like from a 2-lane highway to like a 16-lane toll road. There are so many things we're putting up there right now for communications. The moon is going to have not only communications like this and repeaters, it's also going to have 5 gig cellular communications on it too. So there's thousands of them. When I looked at it, and I was counting them up yesterday again, it's close to 100 different bands and frequencies that are going to be used, right? So it's amazing the technology and where we're going with this, right? I already talked about the SDRs. I do have a hack RF which I use, and it's actually really pretty cool. It works pretty good. It is full duplex too, but it doesn't quite have all the capabilities that this Pluto has. It goes to 6 gigahertz. This goes to 6 gigahertz too. And by the way, this is about $200, just to let you know. But you can get it from Mauser. Mauser has these, and the nice thing is you can put 2 more receive and transmit onto this versus that. But when I was looking at some of the examples, you know, there's lots of code out for this thing. There's lots and lots of code out for this, and the Europeans are writing stuff all the time and the capabilities of this. But I saw a spectrum analysis graph of this thing actually went up to about 14 gigs. So that's why I'm really interested in it, because when we look at the satellites with like what AMSAT's doing with the 5 and dime and so forth, we're kind of considering that too on the communications back and forth from the moon. So it would be 5 and 10 gigahertz, right? And so there might be possibilities we could simulate and do that with this type of device for just a few $100s, which is kind of nice. This is the inside of it actually when it's opened up, and the capabilities. You probably can't see it very well, but there's little tiny antenna ports here and here that are already there that we just snap in an extra cable and we can go with it. There is a Chinese model out there. I purposely did not buy the Chinese model because I have the TAA stuff. We can't buy Chinese stuff. But it actually has taken this design and incorporated the same analog chip onto it and broken out those ports for you. And it's about $100 more, but the features you get, it's already built with the SDR with the 2 transmits, 2 receives, plus it's in the middle boxes, which is kind of nice for it here. You can also input a GPS clock reference to this, which is nice, so you can use the GPS to input the frequency and make it really stable. So the analog devices built this for schools, and so it's just really amazing that they did such a really good job on this and the capabilities of that. So one of the incredible things, because they have done tons of software with this, right, is that, well, what if you used it with multiple antennas in a phased array, right? So the idea here is that if I've got 2 antennas, you know, I can tell which direction that you're sitting at or where you're coming from, right, and tune the antennas for that. And I do a lot of stuff with the Department of Defense, and we're doing that stuff with aircraft. So the skins of aircraft right now are becoming antennas, and they will detect enemies and so forth right away and determine how to target them, right? Same thing with this device. This device actually has that capabilities, and Analog Devices has the code out for this to look at this, and they have a YouTube video out there, and this gentleman did a really good job. He has the 2 receive antennas and a transmit antenna down here, and this code will actually tell you what angle and everything is at, so it's really pretty interesting, and it's something that I think that we're going to use going forward with a satellite. So I was kind of blown away because he actually had gone on Amazon and bought these little antennas. I don't know if you recognize those or not. Those are Kent Brenton's antennas. So I don't even know if Kent knows this yet, so I'm going to have to send that to him. But he set this up as a test, right, and showed how he can move it around on the video, and it was really amazing, right, that having these antennas, you can detect which angle everything is at and which ones to use and how to use it. So this type of technology is really pretty cool and something that we're going to be using going forward with it here too. So this was a attenuator filter for capabilities. We were very fortunate. We got a new member to ARISS. His name's Jim. But he has now gotten us on every social media type thing you can think of, right? So There's tweets, Facebook, whatever. He's got us on TikTok too. I don't know why, but because the board asked him like, why are we on TikTok? But we are on TikTok, and I'm not sure we're really using it, but the rest of them we are using all of these right now, so which is really cool, and we're pretty proud of that. Jim's doing actually a great job with our social media and the capabilities that we have today. So yeah. And that's it. I did build this CubeSat here during Christmas. I put this together during Christmas. So AMSAT has the frame that's 3D printed. I had ordered for our engineering team a 3D printer, and Hunter did the printing for me, and pretty cool. And so during Christmas, I actually found, and I went to Micro Center, and I bought these solar panels for the sides and everything. So it is actually pretty good. I've got batteries inside this running this right now, but it's using a Raspberry Pi Zero, basically, and it's using what AMSAT calls the light board. So it's using the Pico light board for this thing. There's also, speaking of Pico, Alan is designing a CubeSat designed with the Raspberry Pi Pico, which I don't know if you've looked at or gone to Micro Center, but with the wireless version, I think it's $6. Without the wireless version, it's like $3, right? These boards are cheap. It's amazing, just amazing. Yeah, the Raspberry Pi Zero, the thing I like about it is that there is an RTL code that was developed by a gentleman over in France that is using pulse width modulation. It is generating the 400 megahertz signal that this thing is doing. It generates, and it's doing the FM pieces of it too, right? So you don't even need an RF board. The light board actually has an RF filter on it, right? Just a filter on it to make sure it doesn't have spurious RF. So it's just got a capacitor and resistor and so forth, and inductor on it. So I'm pretty happy how this works, and Alan is too. His new design for the Pico board actually has to have a chip on there to generate the RF for it, but the Raspberry Pi Zeros don't need that, or the regular Pis don't need that. They actually do the pulse width modulation, and he's able to get that up. So this is pretty fun, and the capabilities of this is I look at this as an educational type thing, and kind of what we're doing with education. So, yep. Anyway, I'm done. I think they're going to start doing the prize drawing, so I appreciate it, and
Thank you very much.
thank you for coming. Yeah, thank you.
They're not going to go on until we come out.
Oh, perfect. We're done. Okay.